Good morning or good evening, everybody, wherever you are. Welcome to the inaugural episode of Caprica's Workshop. I'm your host, Caprica's Carito. Today's episode is about my response to the so-called Trump Class Battleship announced recently by America's glorious leader. My personal opinion, if you look at the specs released by the Navy, is that this ship is not, in fact, a battleship. Um, my definition of a battleship historically has been tied to the last battleships built, which were back in World War II when everything was about big guns and big armor. However, after the recent announcement by the President and the Navy, I've had to go back and look at that and really redefine for myself what a battleship is. And I've come to the conclusion that regardless of weapons, there is a way to define battleships because weapons change, armor changes, hull shape changes, propulsion means change. So, what is a battleship? Well, a battleship at its heart, as Drachnafil says, is a ship meant to stand in the line of battle. What does that translate to? That translates to a ship that has the best weapons, the best defenses, and the most weapons that we can pack in its hull. It needs to represent a significant step up from the next class down, which in this case would be a cruiser. And it's my personal opinion that the Trump class battleship, and I put quotes around that, doesn't qualify as anything more than a heavy cruiser at best. And as Ryan Zemansky over on Battleship New Jersey's YouTube channel, and I'll link this video in the description. As Ryan said in that video, the Trump class battleship, by the time it gets built, will likely be stripped down to barely more than a destroyer, likely qualifying as a light cruiser at best. So let's dig into this and let's look at my concept of what a battleship should be in the modern era. As you can see on my screen here, I have nicknamed mine the Iowa II class battleship. I have chosen that name because the entire concept is based off reusing the hull form from the Iowa class ships. My battleship design here or concept would have a top speed of greater than 45 knots and an unlimited range with no more than 900 to 950 crew, depending on the Avionics Operations department. And it's spec'd out to have a mission duration of 6 to 18 months. It has a ton of missiles, a bunch of rail cannons, which we'll talk about in a little bit, some lasers, improved CWIS systems, as well as drone swarm defenses, and some aircraft operations space. And one of the keys for the Iowa class battleships was its incredibly large fuel bunkerage. It carried 2.5 million gallons of fuel, which, in addition to being for its own use, could be used to refuel other ships. Modern warships are incredibly thirsty, and they go through a lot of gas. One of the drawbacks of the Trump class battleships, as you see here, is it uses the gas turbine engine. Well, it says gas turbine and diesel powered. My research suggests that diesel powered engines they're not big enough or powerful enough to fit on a modern warship. And gas turbine engines are incredibly fuel inefficient. They have a lot of power per unit, but they guzzle the gas. And this has created a problem where we're having problems sustaining our current fleet logistics and getting fuel to the ships where they are, where they need it. So I've addressed that with my version of the battleship, which will retain that 2.5 million gallon fuel bunker. So let's dig into this now. I started, of course, with the venerable Iowa class battleship hull, seen here without its conning tower and bridge, basically without its superstructure. I have left the two smokestacks in just to give an idea of where this superstructure would fit. The conning tower section would in fact fit right in here in front of this forward smokestack, and it's about 8 decks and weighs a whole lot. So my first step with this ship is get rid of all that stuff that's above the deck. It's old tech, it's outdated. Even the metallurgy today is far more advanced than what was used to create the Iowas in the 1940s. My second step is to rip out all the old boiler steam production plants. I've kept the 4 screws on, but we're going to convert those to run on electric motors, because I have, in fact, let's see, added 2 nuclear power plants, which in my version I've just grabbed a pair of reactors off the Gerald R. Ford carrier production line and dropped them into this hull, which of course means redesigning the interior, but that kind of goes with the territory of creating a modern ship. In order to get this ship floating, we have to update everything about it. Even the metallurgy is going to be different. So we're going to start by dropping in 2 A1B nuclear reactors. These are simply A1As that have been modified to fit into the footprint of a battleship. The second thing I've done is we've replaced the original conning tower with a modern integrated command island, which would include all of the modern radar, sensory, and optical advanced sensory equipment, as well as ECM and ECCM systems. This would be your Spy 6 radar, your Slick 32, and what's the new one? The Sea-Whip Block 3. So all of that stuff is of course going to be in this modern integrated command and control tower, or island as I've decided to call it. I've also included an integrated HUD on the bridge to allow for quick reference, so that whoever's in command of the ship at the moment can tell what the ship's condition is at a glance, where it's going, how fast it's going there, what systems he might need to pay attention to. And I've also included an integrated AR system for combat operations. This would allow the captain, the XO, and other necessary officers to maintain full awareness of the battle space, similar to the way F-37 pilots can see all around their ships, or all around their planes, excuse me. Having that ability to see in any direction, I think, is a great innovation in modern battle tactics. And I wanted to integrate that into this new design ship. So what's next? Well, next we have to look at the primary battery. The Iowa ships as built in 1940, 1941, 1942, I think it was, integrated the latest and greatest military technology of the time. They had great big 16-inch diameter guns, and they had top of the line radar systems and fire control systems. Today, that's outdated, and we're replacing that with modern sensors, modern radar, modern fire control, and guns with a 20-mile range. Well, they're not good for much more than shore bombardment and close-in defense. Unfortunately, with modern naval warfare, a ship equipped with only 16-inch guns is a sitting target, and it will never see the enemy, as it will likely be sunk long before it even picks the enemy up on its radar. So we've gone ahead and we've pulled off those guns, and we are replacing those with missiles, of course. Those being the standard primary battery in this day and age. As you can see here, we've got 3 different missile arrays, 1 forward and 2 amidships. The forward missile array I've set up to be loaded for surface-to-surface combat. This would be your land attack missiles, as well as missiles suitable for hitting lightly armored ships. While the furthest aft missile array, which is also a Mark 41 VLS system, is loaded out for air defense and maybe some light surface-to-surface selections. It is the aft missile array is the biggest one because aerial threats are the biggest threat to this ship. This could be anti-missile missiles or anti-aircraft missiles. And then, of course, we have the HMVLS cells, as I've termed them, or, quote, hypersonic, in quote, missiles. I put that in quotes because one of my favorite YouTube creators, Mr. HLC, and I'll link his channel in the description too, might actually have something to say about whether or not the missiles that fit in these cells are actually hypersonic. And I don't want to set him off, so we're going to go ahead and call these a hypersonic missile VLS cells. There are 60 cells. I've marked them here as Mark 57, but the Mark 57 cells are in fact designed to be placed around the periphery of the ship, so these would likely be Mark 58s or 59s, whatever the next modification is to get them set up to place inboard. And these are, of course, the primary anti-ship and long-range strike missile systems. So what's next? Well, next we have our secondary battery. In this case, I have spec'd it out with 6 twin railgun cannon or twin rail cannons. These are just turrets, 6 turrets that have twin mounted 32 megajoule railguns. Ryan, in his most recent video, mentioned that the Navy has put their rail cannon in the museum and they've quit researching it. But other countries have not. I saw a news article recently that Japan has successfully fired a 32 megajoule railgun. And if we want to keep up with other nations, we need to actually go back to the railgun, I believe, and we need to finish developing that. There's no reason not to. The ammunition for it is far lighter than conventional cannons ammo, and it's a whole lot less detrimental to the environment in terms of CO2 and other carcinogens, as they don't use gunpowder. They just use electricity. So as long as you have something made out of steel that you can throw in that cannon, you can fire it. I've spec'd this out for 6 of them. Now my research indicates that the 32 megajoule rail cannon or railgun is equivalent to an 8-inch conventional cannon. So these are the kind of cannons that we saw on the Des Moines class cruiser and other heavy cruisers, because rail cannons lose their effectiveness rather quickly. They lose their shells run out of power rather quickly. They don't sustain the kinetic energy over the long distances that they can theoretically achieve. So at range, at optimal range, these are going to be no better than an 8-inch cannon, which of course the Navy abandoned that cannon as well, preferring the 5-inch. These of course use ammunition that's lighter than the 5-inch cannon, I think, or possibly, and a lot smaller. You can pack it in. My research indicated that you could pack 12,000 rounds of ammunition for these cannons in less space than one of the barbettes for the 16-inch turrets take up. So we have plenty of space in the Iowa hull to pack in some ammunition for these cannons. And since they use electricity to fire their shells or their ammunition with nuclear reactors powering them, they have an effectively unlimited capacity, which really is only limited by how much ammunition you can pack into this hull. And Iowas have an incredible amount of volume inside their hull. So let's move on to the next one. Anti-air, anti-missile defense. I have spec'd out this ship with 8 G8B Brawler close-in weapon systems. What is the G8B Brawler? Well, it's the GAU-8B. It's a GAU-8 that has been optimized for service aboard naval vessels using a vertical magazine that has been enlarged to hold more ammunition. In this case, I've put on here 2,000 rounds, but we're probably realistically looking at 1,500 rounds. And I've also spec'd them out to be fully retractable into the ship's interior to reduce radar reflection off of them when they're not in use. Also, I've added 4 300 kilowatt lasers. I know the Trump class ship, in their specs, they've listed 2 300 watt and 2 600 watt lasers, but in the image I showed you earlier, they did not actually put the 600 watt lasers on this diagram, and I believe that's because there are no 600 watt military application lasers currently in existence. As Ryan Zemansky from Battleship New Jersey said, by the time this ship, the Trump class carrier or Trump class battleship, is actually built, it's probably going to have lost quite a bit of what we see here and be more akin to a heavy destroyer or a light cruiser. And those 600 megawatt or 600 kilowatt lasers are probably going to be one of the first things to go. Otherwise, they would be on this diagram, which I might also add has changed every time I've seen it. The first time I saw it, the vertical launch missile cells right here were listed as having only 28 cells. And it did not have the 5-inch guns, which they've added right here. Those weren't there the first time I saw it. All it had was a single 32 megajoule railgun, and the 12 CPS missiles, the 2 counter UXS systems, the flight deck, and 4 Mark 30 millimeter guns. There may have been the Mark 38 designation. I don't remember. But it's only weaponry where the missiles, 4 30 millimeter guns, and the single rail cannon, along with 2 lasers, which are shown here. I've equipped my version with 4 lasers. There they are. 2 on the island, which can be fully retracted into the command island to restore or preserve the stealth or reduced radar observability stealth aspects, and 2 on an aft mast, which I've designated as the DEW mast, or directed energy weapon mast, because it houses directed energy weapons. Possibly there could be some flight operation stuff involved in that mast. I don't know. I'll leave that up to people who know how to build ships to figure out. But the 2 on the DEW mast can only be partially retracted due to limitations in the size of the mast and compared to the size of the laser systems and what else has to be in there. So moving on, let's address the elephant in the room: drone swarms. Drones have become incredibly prolific in modern warfare over the course of the Russian-Ukrainian war. And the Ukrainians have proved that they are vitally effective at doing all kinds of damage to all kinds of things. So any modern battleship needs to be able to protect itself from swarms of drones, or even just individual drones. So I have spec'd this out to have 2 high energy electromagnetic pulse emitters, or EMP emitters for short. One is forward on the top of the island and capable of rotating to cover the entire forward half of the ship and protect it from drone attacks, as well as attacks from aircrafts and missiles that get through its other defenses. These systems aren't designed to spoof or decoy. That's all part of the ECCM and ECM suite. These systems are designed to kill the electronics. They're designed to fry the motherboards and the chips inside the whatever's attacking and knock them out of the air. Using these against a missile or a fighter, well, these things are going to keep flying, and there's a very good chance that even if you kill the electronics, that missile's still going to hit. That fighter's going to still be able to crash into the ship. So these would be a last ditch effort against those weapon systems. And primarily they are there to defend against drone swarms, which are drones are far lighter. They're going to fall out of the air quicker. And if they do hit the ship, its armor is going to stop any damage. So there you have that. And finally, we're going to move on to the aviation operations, or aircraft and air operations. I have spec'd this out with a, what I think of as a really large landing deck may actually be kind of small in terms of aviation operations. I'm not sure. But I think it's rather big, especially for, a non-aircraft carrier. I have also spec'd it to be capable of handling an F-35B as well as standard rotary wing aircraft landing on it. And I've also given this an elevator into an internal hangar. Now the internal hangar I've spec'd out is quite large. Large enough to house two F-35B fighters as well as the MH-60 Seahawk helicopter. But I've also recognized that, most naval personnel, naval command, probably isn't thinking about putting a couple of fighter jets on a battleship. So what else might they put there? Well, how about a drone warfare operations center? With 160 feet of flat landing surface, you can launch a lot of different types of drones and even recover a lot of them. So I've also put an option here to put in a drone warfare operations center instead of the F-35B fighters. And that makes this an incredibly, incredibly powerful ship. With its capabilities, the fuel bunkerage, the weapon systems, its speed and duration, this ship can get into places where it may not make sense to send a full aircraft carrier. It can support its escort fleets, the very fuel-hungry Arleigh Burkes that would be likely to accompany this. And it also provides a significant increase in primary weapons power over smaller ships like light cruisers, heavy cruisers, and certainly outclasses the Arleigh Burke class destroyer when it comes to missiles. So what's the cost? Let's talk about. Okay, so I've opened up here my file where I did all the research for creating this, and as you can see here in this file, I've actually put the speed at 35 plus knots. Research afterwards indicated that the nuclear reactors would actually generate enough power, propulsive power, to push the Iowa hull, even at 55,000 tons, up to speeds in excess of 45 knots. But I've spec'd it here for 35 plus knots. It's roughly 850 feet at the waterline, 907 feet length overall at the deck, with a beam of 115 feet again at the deck height. I'm not sure what it would be at the waterline, but it would be similar to that of the existing Iowa class ships. I've also shown here that I've put into A1B nuclear reactors using conventional naming, or the actual Navy naming conventions. Those would properly be called B1B reactors, being designed for a battleship. That's what the A stands for, is aircraft carrier. 1 being the first design for that class, and B being the reference to the people who made it. In this case, I'm calling it a B1B. It's going to be the A1Bs redesigned or relayed out to power the battleship. So made by the same company that makes the reactors for the Ford class carrier. I've also spec'd out a cooling system here, railguns, lasers, and of course nuclear reactors generate an incredible amount of heat, far beyond anything most civilians could imagine. And so I've spec'd out a hybrid system that uses liquid gas to carry heat away from the rail cannons or rail guns and the lasers, and get that down into a radiator where it can be radiated into seawater using existing technology for cooling ships' reactors. It's something that the Navy knows how to do. It's something that they do with every aircraft carrier. And even with all the other ships, they use seawater to carry away waste heat. And there's no reason to change something that doesn't work. I've specified the liquid gas to carry heat away from the other systems because that heat needs to be carried away quickly and effectively. And using a liquid gas is one of the better ways to do that. And it prevents having to pump seawater all over the ship, which is highly corrosive. So also I've spec'd this out, 900 sailors, 650 for an optimized crew, according to my research. Now, I don't know what optimized means in this context, but I would say that would be the minimum safe operating crew, with a nominal crew of around 900 people, plus 20 to 40 people for operating the aircraft or drones. I mean, that's obviously something that I'm not familiar with, so I just threw in a couple of numbers there to make it look good. So what about the mission? Well, as you see, I've spec'd out the standard deployment to be 6 to 9 months with an extended deployment of a year and a half or longer. The Iowa, again, has an incredible amount of internal volume, and it can easily store enough supplies and parts and other consumables to last a year and a half or longer. But what about its missions? Why would we build this? Well, at its most basic, it's a big ass deterrent. That's a lot of firepower floating around out there in the sea, and hopefully the stealth systems mean that people looking at it are only going to see a destroyer, but they know that we have these ships out there. They're not going to escalate conflicts if they know that these ships are in the area. In addition to that, it acts as a group anchor point. The center of a task force or combat group. Again, it's got 2.5 million gallons of fuel that it can dispense to Arleigh Burkes and Ticonderoga class ships, even to frigates. Of course, submarines and aircraft carriers, they don't need the fuel because they're running on nuclear power just like this ship. So it becomes a logistics hub for forward operating task forces. And it reduces the strain on our logistics line. And in addition, it's a massive bit of power projection. A massive ship like this, with the load of missiles it has, can project power into areas that aircraft carriers can't get to, which are very few and far between, but there are still a couple of those types of areas. It also becomes a power projection point in areas where we just don't have a carrier available to send in, or maybe a carrier is overkill. So what about armor? A lot of people think that a battleship needs to have armor. If it doesn't have armor, it can't be a battleship, right? I would say yes. I think a battleship needs a fairly good amount of armor. And as you can see here, if you can read this, I've spec'd this out at 9 inches. The reality is that is purely the advances in metallurgical composition and structure. 9 inches of modern armor plating steel is the equivalent of the 12-inch armor that the Iowa class had back in World War II. So at 9 inches, it has the same protection against against shell bombardment that the existing Iowas have. What I have done is I have extended the armor belt all the way forward to just between the forward rail cannons and the forward VLS array, and all the way back to the stern. I've written in here roughly frame 138. Actually, no, the armor goes all the way up to frame 60, protecting the VLS array from attacks, surface level attacks. But the armored citadel only goes up to frame 160, I think it turned out to be once I mapped everything out, or 138, somewhere in there. The armored citadel encompasses the forward rail cannons and the aft rail cannons, ending at the forward bulkhead of the internal hangar. Again, the belt armor extends from frame 50 or 60 all the way to the stern post, protecting the entire length of the ship. I have also unified the deck armor, for lack of a better word. I'm going to go with unified. I've made it a uniform 9 inches of deck armor all across the ship. That gives it, that same 12-inch equivalent armor. And that's an incredible amount of resistance. But another thing to consider is that no matter how much armor you have, shape charges, modern missiles, they're likely to be able to get right through it with heavy enough missile. The armor is going to protect from lighter missiles, and anybody wanting to fire at this ship is going to have to expend something big and expensive. And we need to be able to counter that. So, in addition to the anti-air close-in weapon systems, the lasers, the EMP projectors, I've also spec'd counter anti-ship missile armor, which would be counter anti-ship missile armor system, which would include crumple zones, reactive composite armor, and all the modern stuff that would help defeat those shape charges and armor penetrating missiles. Of course, the idea with that kind of armor system is to disperse the force and the shock wave. And we do that by creating crumple zones, crumple structures, and reactive armor that creates a counterblast. So then here, I've got my weapon system spec'd out. And aircraft, where did I put the information I wanted to look at in here? I don't remember. We were going to look at the costs. That's right. So let's address the costs. Why would we build this? Why would Congress authorize this expenditure? And how much would it be? According to my research, we're looking at probably 13, 14, 15 billion dollars for the very first ship. It's going to be super expensive. There's a lot of research that would need to happen. Um, we would have to get our rail cannon program back on track or buy from the Japanese, which is kind of how I envisioned us doing it. Let's just go buy our allies' weapons. They've got good weapons. They make good stuff. Um, for the last 50 years, Japan and Taiwan have been in the forefront of electronics development, and they're good at what they do. So let's use what's already out there. So the hull itself is going to cost $2.5 billion. That is no more expensive once you've compensated for inflation. That's about the same it costed to build the Iowa hull back in the 1940s. The nuclear propulsion, well, what's the cost of a nuclear reactor, or a pair of them, I should say? Apparently, it's $2.5–3 billion. We're spending that already on every Ford class carrier. Maybe another $500 million to get it relayed out and certified for, operation and safety. I would hope it's a lot less than $500 million, maybe a few million, but you never know. Special interest groups, they like that government fat. They like sucking on that government spending nozzle. So what about the electronics and radar? Well, we don't need to develop new stuff. We already have it. It's already being deployed on the Arleigh Burkes. It's already being deployed on the Zumwalts and the other new ship designs. There's nothing new. It's just how are we going to put it to get the best coverage? How are we going to set it in there? And that's why I just went ahead and included a fully integrated command island. Because, we have some of these structures already developed. We could theoretically just grab a design that's already in use, drop it on top of the deck, and call it a day. But it's still going to cost money. That's still another $1.5 billion for all those systems. Yeah, what weapons? Well, I'm not sure how much it costs for the cells. I'm not, and missiles are expensive though. The cheapest missiles start at $2 million, and those aren't even the ones that go on the ships. I don't think. I think the ship missiles start at $6 million and go up from there. So we're looking at a few $1 billion getting the weapons mounted, getting them all loaded up. And of course, we'll probably have to do a little bit of research for effectively cooling the lasers and the railguns. And also I expect it for twin mounts, and current railgun technology is all just a single barrel per mount. So there's going to be some research and development in that too. And my AI assistant also noted out some integration and software costs, $1 billion for writing, modifying the code to use the high energy projectors, lasers, and railguns, and tying those into existing combat systems like the Aegis system. So all in all, we're looking at a fairly expensive ship here. But by the time it pencils out, because I've spec'd it for right here you can see 4 to 6 ships of this class. Let's be realistic, we haven't fielded 20 to 25 ships of any single class since World War II, other than the Arleigh Burkes, and we're already starting to retire Arleigh Burkes because they've been in service for 30 years. Their systems are outdated. The Arleigh Burke has been an incredible platform, and it's been incredibly prolific and there's been a couple of times where we've just ordered more Arleigh Burkes because newer designs have fallen through. So outside of the Arleigh Burke, we've never fielded more than a dozen ships of any single class, more than a few ships of any single class since World War II. And the reality is, we're not going to field more than a dozen of these either. What's the cost comparison? When they even out over the course of 6 ships, per ship, we're talking about 80% of the cost to build a Ford class carrier, or 120% of the cost to build a ballistic missile sub, or the cost of 4 to 5 Arleigh Burke destroyers. Now, that is arguably the biggest consideration there. An Arleigh Burke carries nearly 100 missile cells, so 4 to 5 Arleigh Burkes would have more missiles on them than the Iowa 2 that I've spec'd out. But the reality is the Arleigh Burkes can't offer the sustainability that the Iowa 2 would. So when we move down here into the is it worth it question, the value proposition, $10 billion, $11 billion, it's a lot of money. Is it worth spending that? In my opinion, possibly, probably. I mean, we're talking about 4 different ship roles here. If you built all 4 of these different kind of ships listed here, a cruiser for air defense, a destroyer for anti-submarine and surface warfare, a submarine to carry the hypersonics, and oh yes, the unarmored fleet oiler for refueling that destroyer and that cruiser. That's 4 different ships whose total cost would exceed the cost of the Iowa 2, and more importantly, who would actually require even more sailors than the Iowa 2, I think. So is it worth it? Yes. The Iowa 2 provides a solid weapons platform. It has a solid close-in knife-fighting range weapons suite to defend itself from fast attack ships and frigates that get in close. It has a solid long-range attack profile, and it carries sufficient fuel to keep its escorts on station and in the fight far longer than our current logistics chain. So, in a nutshell, that is my rendition of what a modern battleship is. Do you agree? Do you disagree? Let me know. I'm really interested to find out what people think.